Hello and welcome to VMware 2021 and VMware Blockchain Getting Started guided workshop for the HOL 2288 hands-on lab. In this session, we will be talking about VMware Blockchain. We will introduce you to the lab. We will discuss about how we constructed the lab, what's the lab experience, and also my colleague Tony will actually guide you through some of the lab modules in the live setup. So before we jump into the lab, let me briefly introduce three lab captains who worked on this year VMware Blockchain Lab. So my name is Gintaras Pelenis. I'm a blockchain specialist covering EMEA region. Today with me on the session is Tony Bailey, which is my counterpart in America's blockchain specialist as well. And we also have another gentleman, Anup Jalan, who is a staff SC and a blockchain subject matter expert located in Americas. So all three of us actually spend a number of months building and updating a new VMware Blockchain Lab, which you all will be able to take through the VMware 2021 and beyond. So without further ado, let's start with a short introduction of what VMware Blockchain is and covering some of the key aspects of the product as such. For those of you who are not familiar too much with the blockchain, I'll start with a brief introduction of the core elements of the technology, right? And we'll try to talk in a simple concept of an application, running on the machine, which we're all familiar with, right? So we've been building these applications for a number of years now, and they've all been running on servers and virtual machines. Lately, all of that is transitioning towards container platforms, things like Docker, or VMware Tanzu Kubernetes grids, and similar, right? If we talk about distributed applications, right? So really, it's extending these traditional applications now and allowing them to run in distributed fashion. So some of you being familiar with different cluster type of technologies, or the same kind of K8s applications, Oracle RAC clusters, and similar things. So taking that distributed approach and extending that even further, we have these decentralized applications which run on blockchain platforms, also known as distributed ledger technology platforms. And really, fundamentally, when you think about it, what's at the heart of the blockchain, and it's very similar to a distributed system. A blockchain system is really also made up of multiple machines or nodes. But really important thing here is that these nodes in a blockchain maintain a shared state, which can't be changed without really consensus or agreement between these nodes. And meaning that, different malicious nodes can't alter the data in the blockchain. And also, unique aspect of it is that it also enforces the execution of these decentralized applications, also, known as smart contracts. And smart contracts are really, applications which share that kind of multi-party process, or they actually design that process and lives on the DLT platforms as such. So instead of having a bunch of discrete applications running on discrete machines or discrete servers, you actually place all of that business logic and automation of that business logic on top of the blockchain platform and enforce that contract execution as such. So the DLT system is really a combination of consensus mechanisms and cryptographic techniques, which allows us to link blocks together cryptographically, validate them, provide consensus and global ordering of that systems, and fundamentally create a shared and trusted source of truth, where both the data and the application execution can be trusted. Now consider a blockchain as smart contract in the context of the business network. When multiple parties in the business network interact with each other, such an ecosystem of financially trading partners or global supply chain partners, where the parties really kind of work daily with each other. By using blockchain, the parties can have a shared source of truth. They can trust the data is valid. They can also trust that execution of any transactions between them is also valid. In a nutshell, this is what is at the heart of the blockchain. And now when you consider that a smart contract can be just about any business logic, really the possibilities are limitless. Programmable money, mutualized infrastructure, supply chain provenance, traceability, non-fungible tokens, and much more. Now let's look at the transformation that blockchain is really enabling. And many of you recently have heard about, the rise of NFT assets on non-fungible tokens. Many witnessed the rise of Bitcoin and different, altcoins as such. So, these are all digital assets living on these distributed ledger and blockchain stacks. So when you think from the enterprise standpoint, we really, see traditional legacy multi-party systems where silos exist between these parties and they have disparate data and processes between them. Messages needs to be sent back and forth between these parties when they interact, and then, different unmatched data sets between these different parties needs to be reconciled. The silos in messaging really leads to delays in processing due to data reconciliation. It also leads to errors and manual steps to recover from these, mishaps, if you will, right? And it also leads, to really increased cost and business risk, right? Which can be both counterparty risk or just, single party having a huge mismatch in data. And similar things in financial services that causes settlement risk, also causes compliance risk and different aspects. With blockchain, really a shared source of truth is enabled between these parties. Now, parties have the same shared view of the data, which removes the need for data reconciliation. And as we already discussed, through smart contract, blockchain enables shared and automated workflows between those parties. So meaning that the message-based systems are now transformed into these synchronous API-based systems, which dramatically reduces errors, improves multi-party interactions, reduces business risk fundamentally. This is really at the foundation of the transformation being enabled by the blockchain and actually visible in the industry nowadays. Now let's look at some of the business challenges where blockchain really kind of, delivers value and which kind of considerations enterprises are taking while, choosing or evaluating blockchain for enterprise use cases. While really that trust and integrity that blockchain delivers has a lot of potential for enterprise use cases, this is not enough. Along with trust and data integrity, different aspects like privacy, performance, efficiency, capacity management, and predictability of costs are really important. They need to be delivered in a way that does not compromise trust and integrity. So privacy is fundamentally required for businesses, in these complex multi-party interactions. They also sometimes are enforced by regulatory reasons, right? You wouldn't really love your competitors, to be able to see, your interactions with your partners on the same network. On the other hand, performance is really, coming from the pure enterprise legacy where we, build systems to really scale to provide that consistent performance. We need faster transaction finality. We need high throughput and low latency for high volume use cases. And we're seeing, use cases with many millions of transactions per day happening on VMware blockchain platforms. Efficiency, many of you may be familiar with this, tremendous inefficiency of proof of work mechanism, for consensus. So things like, Bitcoin or Ethereum networks or some of these public networks, where transaction, finality may take minutes, if not hours, right? And it also draws enormous amount of energy to provide that consensus capability. And it's really, environmentally not acceptable thing. So VMware blockchain really helps to solve these challenges by providing near instantaneous finality and very efficient consensus protocol. Capacity management is another huge problem, right? So blockchains are considered to be immutable, but use cases with high volume of data, particularly in capital markets, financial markets, even supply chain, they may generate terabytes of data per day because we have this immutable system where we fundamentally are not changing any of the entries. We just keep adding them and progressing forward with it. So that data needs to be able, to prune from the system, while at the same time adhering to the principles of blockchain and doing it through consensus. So fundamentally, not only we want to make sure that, the hottest and the required data is kept in the system, preserving that trust and integrity, but also, some of the data which may not be required anymore can actually, be removed from the network whilst all of the parties basically agree to it, right? So we reach that consensus-based decision. Predictability of cost is also kind of, an important one, right? Because if you think about the public ledgers, things like, again, big Bitcoin, Ethereum, or any other altcoin networks, we all witness the volatility of cryptocurrencies, volatility in gas prices. We see that sometimes these transactions cost enormous money to be executed on these public networks. So therefore, enterprises really need predictability of costs in terms to be able to run the business. You can't actually, do the business with your, counterparties, with your partners, basically. If one day that single transaction will be costing, pennies, another day it may go as high as a couple $100 per transaction. So over and above this, enterprises really need a blockchain platform which is flexible, so they can adapt and expand to the rapidly changing environment. Where they can actually deploy new use cases, they can deploy, proven use cases, and fundamentally have ability to scale in the future. And it also needs to be extremely robust to meet the bar for the business critical, mission critical use cases in these highly regulated environments, or cross country environments as such. So now let's look into how we've architected the VMware blockchain platform. So first of all, we started with this foundational layer, the layer which provides all of the core blockchain technologies, the cryptography, consensus mechanism, global ordering, fault tolerance, and other aspects of it, including performance enhancements and privacy features. Then on top of that, in traditional VMware fashion, where we kind of abstract different things, we created that virtual execution environment for running smart contracts or running distributed applications. So this layer abstracts away the complexity and also enables these multiple contract execution engines to be run on the same blockchain. Importantly, different languages such as DAML and Solidity for Ethereum, Ethereum virtual machine, can be supported on same VMware blockchain. And in this lab, we actually will demonstrate how DAML and Ethereum virtual machine can run on VMware blockchain platform, and covering basically different use cases we see. And Tony will actually be showing one of them later in this presentation. Then we glue those two layers with a privacy-aware authenticated storage stack. This is where all of these blocks and transactions actually being stored, together with the privacy-aware data. And again, later on in the demo, you will be seeing how that, translates in the platform, how we can actually ensure different privacy mechanisms and data segregation as such. And of course, on top of that, there are all standard application interfaces, which provides basically an entry point towards the ledger. So for DAML, we have a DAML ledger API. For Ethereum, it's Ethereum JSON RPC API. And on top of that, we really have these business critical applications in your smart contract language of choice. So to summarize, VMware Blockchain brings the innovative core blockchain technology together with ease of use and extreme robustness. This innovative core maintains the highest levels of data integrity and trust. It includes the features needed to meet critical enterprise requirements, including privacy, performance, efficiency, capacity management, and predictability. We then offer this as a platform that abstracts away the complexity and provides these virtualized environments to run the smart contracts with flexibility and extensibility, supporting TAML, supporting Ethereum virtual machine, and providing different deployment options, whether on-premise, in the cloud, or hybrid. And finally, we really aim, for extreme robustness and comprehensive enterprise-grade support, offering the 24/7, VMware global support with dedicated subject matter experts for our blockchain offering for our customers. So with this combination, customers can actually start the journey and grow and adjust, their business, their use cases, to meet the critical requirements they have raised over the course of the years for existing systems. So that was the short introduction into the VMware blockchain. Now let's briefly touch on how we've been constructing this lab, right? So at the high level, VMware Blockchain Getting Started Lab is a virtual vPod presented as hands-on lab available for customers, to consume through our VMware Learning platform. It has a number of virtual machines. So, components like control center desktop virtual machine, which provides that fundamental user interface, for all of you to go there and consume these labs. Then we have a number of virtual machines hosting different implementations of VMware blockchain together with digital asset modeling language and Ethereum. So we have DAML on VMware blockchain. We also have Ethereum on VMware blockchain running there in two separate virtual machines. Basically, all of these components packaged as Docker images, Docker containers, and running within these single VMs. We also then have a distributed application node or virtual machine where we actually host these different sample applications, so it's like supply chain for Ethereum stack and some of the DAML IOU examples for the DAML module as such. There are also two interactive simulations in the lab which cover two of the modules, and they were created specifically, to address the limitations of the hands-on lab platforms. We don't have unlimited resources. So therefore, we use an ISIMs to demonstrate deployment capabilities, but also operational management capabilities using things like Tanzu observability and, VMware's log inside solutions as such. So now I will hand over to Tony, who will introduce you to the lab, introduce you to the modules, and also walk us all through some of these modules in a demo environment. So over to you, Tony.
Thank you, Gidris. And welcome everyone to VMworld. I'm really glad to be talking to you today. Go to the next slide. Our hands-on lab is really a set of 5 modules. Effectively, the material Gintris just took you through was module 1, is that introduction to VMware blockchain and some core blockchain concepts and our architecture. The demo I'm going to be giving very shortly is going to be the deploying VMware blockchain module. And then the next 2 modules are actually using VMware blockchain, an Ethereum version of VMware blockchain for supply chain management, and using VMware blockchain with DAML in a sub-transaction privacy example that we're also going to demo here in this workshop. And then lastly, as Gintris mentions, the module that talks about the operational management and supportability and maintainability of VMware blockchain. So having the background from Gintris, I'm going to kind of move into the deploying VMware blockchain piece of it. But before I actually show you the demo, it's important to talk to you about sort of the components of our architecture, not the hands-on lab, but the components of VMware blockchain itself. And if you go to the next slide, Gintris, we really effectively have 2 nodes, right? VMware blockchain is a network of nodes. The nodes are just VMs running on vSphere. But in the concept of blockchain, we have 2 types of nodes. We have replica nodes and client nodes. And the replica nodes are the Byzantine fault-tolerant state machine replication. They are the blockchain aspect of the network. They actually validate, via cryptographic signatures and process all those incoming transactions. And then they actually execute the smart contracts, the shared logic, and create that shared state and commit those via consensus and so on. They create the nodes of the replica network create that single source of truth. And the important thing here is that it's a malicious fault tolerant, a Byzantine fault tolerant, malicious fault tolerant single source of truth. So we guarantee that the network is available and correct and complete. The terms are safety and liveness. We guarantee that even when up to 1/3 of the network is unavailable or malicious, acting in bad faith. And it's important to note here when we talk about that, malicious fault tolerance, a lot of people think about hackers and what happens if this node gets compromised and others. And that is one aspect of where blockchain can play. But the other aspect of it is these are typically multi-party systems, and it has to do with where the parties have different incentives. So for example, I will pay the other party when something happens, but the other party is going to wait to report that something happens so that they don't have to make their payment right away. And those kind of ways that people or organizations will game the system can also be thought of as acting in bad faith or against the shared rules that we've all defined, right? So you can take those rules around when something happens and how we all play together, and all of that can be encoded as part of the blockchain network, and the blockchain network will ensure that those rules are enforced fairly across the entire ecosystem. And if you go to the next slide, the other component of our architecture is client nodes. They are basically the Byzantine fault tolerant interface to the replica network. So they actually provide that transaction interface to you receive, whether you receive a DAML transaction that is run through the DAML execution engine to the replica network, or it's an Ethereum transaction into ETHRPC to the replica network. They provide that interface to the network. And an important thing here is that it's a Byzantine fault tolerant connection to the network. This picture actually shows the client node connected to the replica node on the left, but not really. It's actually connected to the entire network. So when a transaction is sent to the network, the client will actually receive confirmation back from the entire network, right? And will only actually register that the transaction has been committed when it receives a consensus that says, I've seen at least 3 of them respond back to me that said they processed it and all received the same answer. So again, you get that malicious fault tolerance interface to the replica network. The client nodes are also how we ensure privacy that typically is defined within the smart contracts and defined by the execution language, but as well as physical data segregation. So when we decide that a smart contract says this data is available to only this party, then that data is only sent to the client node that party is allocated on. And we'll get more into that in the privacy example we're going to show later. But our client nodes are also the way that we actually provide fault tolerant interface to the replica network. We actually have what's called client groups, and where you can actually have multiple client groups that actually provide a HA interface to your upstream application, and also that Byzantine fault tolerant network to the replica network. And so together, if you combine those in the next slide, you'll see a typical topology. Again, a simple development topology would be that 4-node replica network, ensuring that the network is complete even if entire replica is compromised, or in this, if it's deployed across multiple data centers, if that data center is compromised. In this example, deployed with 2 client nodes where you have some parties allocated to one and some parties allocated to another. And as I was mentioning before, this is part of our mechanism where with, for example, Alice and Bob, when they're both allocated to the same client group, the same client node, it's the DAML smart contracting language, the rights and obligations and other things that are authored inside the DAML language that allows and ensures what data Alice can see and what data Bob can see. And actually, VMware Blockchain combined is the component that actually ensures that all that data is only stored on that node and none of Charlie's data is mixed in between it. So this is what we see as a very typical topology and structure. And so with that, I'm going to actually get into the demo here, and I'm going to, let me share my screen. And I'm going to take you through a couple options. So again, because VMware Blockchain is just VMs deployed to vSphere, we actually have lots of capabilities around how that is deployed, the topologies it is deployed against, and so on. So I'm actually going to show you 2 different ways that it's deployed and a couple different topologies. The first one I'm going to do is actually using our SaaS tools, right? And we're going to actually start by going to VMware Blockchain, where we have a UI to talk about how you're going to deploy blockchain. And really the key thing you need to do is what you're going to say is, where am I deploying that blockchain? And depending on the ecosystem where you're working with, you could be deploying a dev environment where you're going to put everything onto a single data center. You could be deploying a high availability ecosystem across multiple data centers within a single client, or you could be talking about different data centers at different organizations, right? But from our perspective, we just think of those as zones. They're target zones on where the blockchain node is going to be deployed. And in our case, we have these nodes, or zones, and within a zone, you can actually see this is all I'm really defining here is the vCenter endpoint. So these are just VMs deployed on vSphere. So I have a vCenter endpoint with some very typical things around saying what resource pool is allocated to it, what storage, where is it stored, and so on. But we also because the product is very focused around enterprises, we're focused, we provide all the capabilities that enterprise needs for everything else that they need to do, right? So for example, how do you do manage logging? So the abilities to actually send logs and forward logs to logging services, the ability to manage metrics, to have your own container repository, to do your own validation of the containers that you receive, and even things like inbound and outbound proxy communication. So these are all things where you basically say, part of this zone is how I connect to it, where it stores all its data, and the definition of the infrastructure that that node is going to be deployed on. And then when you define those zones across all those data centers, that becomes just the target that we're going to deploy to. So now I'm going to actually go to do a deployment. It's a very simple choice. You're going to choose, am I doing DAML or Ethereum? And our first example, we're going to do a DAML blockchain. Give it a name, demo. And then we're going to choose a 4 replica deployment. So we could do 7, 10. Again, you're looking in these increments where you can guarantee that a third of the network won't be down at any one point. So a 4-node network guarantees safety and liveness even in if 1 node is compromised. A 7-node ensures that in case that 3 are compromised, and so on. So in this case, I'm going to do a 4-node replica network deployed across these 4 data centers. And then this is where I define those client groups. So we remember, client groups are how we do physical data segregation, right? So client group 1 is only going to be able to see the clients that are allocated there will only see the data. Well, physically, their data will exist only on the nodes that we deploy to this client group. And I'm going to pick 1 client node and put it in 1 data center. And then for HA, I'm going to pick another node and put it in a different data center. And now I'm going to create another client group 2, right? And I'm going to take, for HA, I'm going to put a node in 1 data center and add another node and put it in the other data center. So I have 2 client groups that'll have physical data segregation and HA availability with a pair of client nodes in each client group. You can actually define the sizing, number of CPUs, memory. You can actually do custom sizing. I'm just going to do a small deployment for our demonstration today. And then you click next. And then you're again reviewing what you're deploying: a DAML blockchain, the sizing of the blockchain replica and client networks, and what is deploying where. And in this case, I have a replica network in each data center and client nodes across all the data centers as well. And then actually click and deploy. So I actually have this sped up for our demo today to see what's happening, but really what's happening there is we're actually going out and creating all of the VMs. We are downloading the necessary components. We are actually connecting all of, establishing the networking and the mutual TLS between all of the nodes. We're actually creating all of the necessary signing keys. We're actually establishing consensus across the nodes, and then we're actually using the consensus to rotate those keys so that even the provisioning services don't have access to those keys, etc. All of the hard things that are required for deploying a blockchain network are all buried into this, and all you have to specify is what nodes do I want deployed and which zones. And again, just as a reminder, this is just these are just VMs on vSphere. And so you're going to see inside vSphere, I'm really just getting VMs that are created that are actually then doing all of that work to stand up and run the network behind it. So that is an example of our cloud service user interface for defining and deploying a blockchain. And I've done a demo blockchain. And now I'm actually going to switch to doing an on-premise version of the deployment using what's called our VMware Blockchain Orchestrator. So our Blockchain Orchestrator is an OVA appliance that you deploy in vSphere into your data center. And when it's a Photon appliance, so you're going to log in this case, I have VS Code sort of connecting to a terminal session on it. But effectively, that Orchestrator appliance has all of the same capabilities for configuring and deploying blockchains that were being used in our SaaS service. And but instead of having a UI, it's all done through JSON descriptor files, right? So in this case, we have descriptor files that describe our zones. Again, it's the same kind of information we were putting into the UI in the SaaS version, which tells us where we're going to put it, the resource pools, the networking, and so on. And then in this case, I'm going to show you an example of an Ethereum one. But again, I'm just going to define the network I'm going to have, the replica nodes I'm deploying and where I'm deploying them, and the spec and size for it. And once I do that, there's a set of commands, very simple commands, where we basically set a few parameters to point at those, and we're going to go run those to actually do this today. So I'm going to copy those, and I'm going to paste those into our terminal here. And what you're going to see is that we're actually running, again, the same provisioning services that we used to deploy in the cloud service are now happening in from the orchestrator. And now I'm creating VMs again in the same vSphere data center. And if you click on the one VM, you're going to see, give it a little bit, it'll actually boot up it'll finally boot up. And again, this is a bit sped up for the purposes of our demonstration today. It's actually established, it has created the VM. It has downloaded all the necessary components to run our blockchain. It's done all of the networking, established the consensus crawl, et cetera. And actually, it's also stood up the Ethereum ETHRPC endpoint. So if you come back to the output of our deployment service, you can actually get the details around what was deployed and where. And you'll see that it's actually deployed on this node. It's deployed the client. In this case, it's the Ethereum client endpoint is listening on 8545 on 10.70.22. So I can actually, if I close this and come over here to Postman, right? I can actually go into Postman, and I can confirm that this should be using the same IP address that I had set it up originally, 10, et cetera. Then I can come over here and I can actually do a post to the ETHRPC endpoint. So again, this is Ethereum standard. These are standard Ethereum functions that basically say get a block number, and I send that to an ETHRPC endpoint, and I actually get the result back that says, yes, it's running. I have my blockchain, and do it again. And I can see, yes, it's actually Continuum Advanced, to just as a quick, simple test to confirm that both the blockchain is up and running and that it's supporting that Ethereum standard. And so that is effectively the lab that you have for module 2. And really what it highlights is a few things. First of all, that the blockchain network is just VMs deployed to vSphere, which one means ease of operations and all kinds of things for your operation teams that are supporting it. It's all tools and stuff they're very, very familiar with, but it also makes it very, very simple for the deployment. And it means we can support all kinds of topologies. We can do it on-prem, we can do it Office, those anywhere you can effectively get an vSphere endpoint. You can do it in on-prem, in the cloud, and lots of places, and all kinds of hybrid topologies that we can support. And then given that target zones of deployment, all of the bootstrapping and everything else that's needed to deploy the demo Ethereum blockchain is all handled by VMware Blockchain. So let me pause there, and I'm going to switch now to going over our privacy demo. So I'm going to switch so that was module 2. Module 3, you're going to see, is actually using this Ethereum blockchain to actually, in the context of a supply chain use case, and it's actually more focus on the nature of the contracts that you can write and how you can use that to effectively in the supply chain space. We're gonna let you guys do that on your own. We'll address any questions you guys have as you're doing it. But we did want to walk you through another example using DAML. And so I'm gonna switch us over, and I'm gonna walk us through module 4. All right, so module 4 is really focused on DAML blockchain deployment and leveraging that. Again, blockchain is already deployed. And as Ginteris mentioned, within the HOL, it's deployed as multiple containers all on a single VM as a way to constrain resources and so on. But from our perspective, you still hit the same as a developer, you don't effectively know the difference. You still just point to the appropriate interface. For an Ethereum blockchain, you point to ETHRPC. For a DAML blockchain, you point to the DAML Ledger API that you're going to see and see how that works. So for our example with DAML, right? What we're going to do here is a very simple DAML example. For those of you that aren't familiar with DAML, it is a domain-specific language that is very, very well suited for anywhere that you're talking about rights and obligations and defining stakeholders and who can see what, right? A lot of these multi-party workflows fit very, very well in this space. I am doing a trivial example with an IOU. There's a DAML marketplace that has much more elaborate use cases for others to explore, but the simple IOU, I think really points to a lot of you can understand a lot of the capabilities easily without having to understand all of the financial complications of the things that are actually happening behind the scenes. So in this case, I've downloaded their DAML Quick Start SDK. The module actually has a link to that, so you can do this on your own. And what you're going to see is a very simple IOU contract that allocates a few parties and others. And so what we start, the very first thing we do, right, to make things simpler, instead of using the lab manual, I've actually copied the commands over. So the first thing we're going to do is we actually need to take our DAML contract, compile it, and deploy it to VMware Blockchain. And that actually is done simply with the upload dar command. So it actually compiles that into a dar file, which is their packaged version of the contracts, and it actually uploads them to the VMware Blockchain. Takes just a few seconds, not super long, and you'll see that the DAR was uploaded successfully. And now what we're going to do is we're going to allocate the parties that we have defined in our DAML contract. That you saw we had Alice and Bob and a US dollar bank and a European bank, etc. And you're going to see, again, just to confirm, we now have those parties have been now allocated against that first client node. And again, what you're seeing, sorry, pause there. So now that I have that running, what we're going to do is we're actually going to use the DAML Navigator, right, which is a tool provided by DAML that allows just from simple access to the contracts and choices that have been defined in your smart contract. So you run the Navigator service, and what that does is it actually opens up a web service where you can actually, a web page where you can actually go in and now act as those different parties. And so now what we're doing is we're actually exercising that DAML contract on top of VMware Blockchain. And so in this case, again, as a simple IOU, we're going to start with a bank issuing some dollars. So we're actually going to come in and we're actually going to take this IOU contract and we're going to create another IOU. And because we're the bank, I'm going to create an issue to myself before I pass it out to others. Let's do 10,000, $10,000 that I'm creating as an IOU to myself. So I'm going to go create that contract and issue those IOUs, right? It takes a second, just briefly. And now you can see I actually have IOUs that are owned by the US dollar bank, et cetera. And I can actually take those IOUs and I can do something, I can actually split off, let me split off 10 of those. And now if I actually go back to my issued IOUs, I have this and I have 10, and I can go take these 10 and I can go transfer them to Alice as an example. Okay. Now, if I go in and I go look at Alice, I can see, and again, because I can't obligate Alice to take the IOU until she says so, what I actually have is an IOU transfer that Alice goes in and says, yes, I actually accept the IOU transfer, that I now have that IOU to the bank for $10, and I can submit that. And now what you're going to see is Alice now has that IOU. But again, now Alice hasn't issued any, but if you go back and look at the bank, you can see that where the assets are and who's owned by them. But the other thing, again, because Alice now is the owner, even though she wasn't the issuer of those, she actually has rights on that IOU. She can actually go take that and she can actually go transfer it to Bob as an example. So she'll go take it, transfer it to Bob. Again, she can only offer it to Bob. Bob actually has to go in and accept the transfer. So he'll go in and accept the transfer. And now you'll see that Bob actually has an IOU. It was issued originally by the US Dollar Bank. It's owned by Bob. And if you go back and look, Alice no longer sees it. And if you go back and look at the bank actually still knows where everything is allocated. So again, this is a bit of a highlighting the capabilities of DAML and where it fits, right? And when we were talking about privacy, right, again, the combination of DAML and VMBC, right, in this aspect, all of this data is located on that client node. And in this case, if we go back to this, it was, in our example for Hands-on Lab, it's a container running on the space, but listening on 6861. So that client node listening on 6861 has those parties and has all that data. And now what we can do is we can actually start up and look at the other client node. So if I go over to the other client node, what you're going to see, because it's in a different client group, right? Oops. And I go list the parties. There's no parties there, right? So what I'm going to do is I'm actually going to go allocate a new party, Charlie, on this new node. And now that I'm going to start up another instance of the DAML navigator pointed at the other client node. And now, because the blockchain is providing a single source of truth, what I can actually do is, as Bob, right, even though Charlie doesn't exist as an entity on this node, he exists as an entity as part of the shared ledger, I can actually go and make a trade to Charlie, right? And I can submit that trade. And now, again, when I come back to Bob, again, it's a transfer, so I have to actually go in and start up a navigator connected to the other client node, and I can log in as Charlie. And again, I have to accept that transfer and give it a second. Right, and now what I have is Charlie as the owner of a contract that it was issued by that US Dollar Bank on the other node. So now what's happening is because DAML supports the sub-transaction privacy across all these other parties, the piece of the data that Charlie is authorized to see physically exist on the client node that he's connected to and he's allowed to see it, and the pieces of data the US Dollar Bank is allowed to see are physically exist on the US Dollar Bank node. Between the combination of DAML and VMware Blockchain and the deployment of the replica client nodes and client node grouping, we can actually provide hierarchical privacy that ensures only the people only see the data that they're authorized to see based off of the DAML models. So that is the focus and of module 4 that you're going to go through. And so we'll be here to help you with questions and challenges as you run through all of it together. And so we really wanted to just say, let me share this. Thank you for spending the time with us today at our VMware Blockchain Hands-on Lab guided workshop. Thank you very much.